to continue that growth that Moore's Law had, but now with some other technologies. And this is going to be the topic of my talk. Specifically, there's a lot of heterogeneity nowadays, and I will focus on one specific technology, that is Memristor-based Accelerator, which we call dot product engine. I also want to point out that this is really a result or work of many, and by no means was it only my own contribution. Specifically, there are some key PhD students, Ayush Ankit from Purdue, Izzat El-Hajj, at that time of UIUC, by now professor at American University of Beirut, Sita Huang from UIUC, still doing his PhD, and Ayush by now has been employed as at another software company. And then key professors who were collaborators, Wenmei Hu and Kaushik Roy. But then there are a number of my colleagues from HP. Some of them are mentioned throughout the talk. Also, these three phases have been published at some premier conferences and journals. ACM ASPLOS last year, Transactions on Computers actually appeared. This is incorrect, it appeared in August, and then ASP-DAC is to appear next year. Just a few words about the type of work we do in labs. We do innovation, but the meaningful one, as we like to call it. So some of the old-timers here who are watching may remember a programmable desktop calculator or the pocket calculator, but also inkjet printer and a number of other innovations that came out of labs. What we do is something in the spectrum of 2 years and maybe all the way out to 20 plus years. And what I'm talking about today, Memristor, is some of these results that came after 20 years of exploratory research. But then what we do is we try to feed that into the business units for products, which are more of evolutionary, whereas what we do is revolutionary. I already mentioned the slowdown of Moore's Law. This is this purple curve at the bottom, compute, but it's complemented with unfortunate growth, explosion really of data. There's exponentially increasing data, exploding data sources. There's shrinking time to action. And no matter how you slice it or dice it, especially with microprocessors, if you look at a transistor, single thread performance, frequency, all of them are slowing down, whereas, as I said, data is continuously doubling. You can also observe the history, how it all happened. So maybe 3 years ago, we still had traditional data centers. So Walmart transactional database was about 40 petabytes. It was all structured data, all tied to individual customers. At the same time, if you look at human interaction data, there's about 4 petabytes of data generated for Facebook across 2 billion users. Then if you look at the cars with all the sensors, there's about 40,000 petabytes or 40 exascale per day. So, and that source of many sensors that are providing it with all over. So we are switching from user-centric to human interaction with many devices to many sensors. That's where this explosion is coming from. There are many intelligent edge opportunities for machine learning and AI in this setting. So we are switching from traditional CPUs to accelerators, which is driving all this growth with all these devices, cameras, not only on cars, but the airport, stationary, etc. For this, we are offering 3 solutions. One is unconventional architectures. The other is unconventional